Hi, all of you. Good afternoon. We are online. Streaming fine. Audio and the video fine. Okay, fine. Take it. What happens sometimes is these software systems, because some of the services are also, other service providers. So they keep updating those systems. So when they update, there are always some problems when the traffic bumps up. Okay, so fine. I think it's managed now. We had problems for one day. Hi, all of you. Good morning. Good morning. Honey Singh. Yo. I hope you are keeping better these days. Hi, Ayush. Good afternoon. Okay, Adarsh. Shouldn't be a problem today, I hope. Aman, Anubha, Puneet, Vijay, Charu. दोपहर की नमस्ते. अच्छा. Good afternoon. Water vapor absorption. Yes. Water, see, it's not 0 types. Water vapor and to some extent some oxygen also. They can absorb a very small amount of insolation. Even IR, the infrared also. There is some small absorption of IR while insolation by oxygen and water vapor. But it's not significant in terms of increasing the temperature. Ignore that, Nikita. Okay, fine. Thanks, Adarsh. ELR, and how is it related to surface? I'll repeat some of those points. Fine, no problem. What is continental position? Away from the coast is continentality, inside the continents. So like Delhi is a continental position, as in away from the coasts. Along the coast is coastal, away from coast is continentality. Good, Ashwin, nice. What is hydroscopic nuclei? Anything which can absorb water or attract water. So dust particles, salt particles are hydroscopic substances, small substances which can absorb. No. IR is more. Yes, in the 3-4%, correct. And homosphere, yes, I said no. By and large, if you look at the entire mass of atmosphere, the bulk of the mass, jo lower layers mein hai, it is very well mixed, except for some of the variable gases and substances like dust particles, water vapor, chhod do aap. The bulk of it is very well mixed. And if you look at the upper layers, yes, there's segregation, but usme bahut kam hota hai. I said about 99% of atmosphere is over by 40-50 kilometers. 99.9% is over by 40-50 kilometers. So at the height of 80 kilometers, kya hi bachta hai? Even if you have segregation there, we say for much of atmosphere, the atmosphere is very well mixed and it acts like a unified gas. Aerosols ki bahut sare sources hain, artificial, even man, and also natural. Yes, ultraviolet rays are entirely absorbed by the ozone layers of the stratosphere, correct. Okay. Wow, Ayush. Ayush is requesting, sir, can you increase the pace of the class? बेटा ऑफलाइन होते हैं ना, यहाँ पर पत्थर पड़ जाते हैं आप पे. ठीक है. वैसे भी these days we're living in societies where lynching is pretty common. The good thing you are online. आप सुरक्षित हैं. ठीक है. Otherwise, आयुष्मान भारत से लेकर क्लास बीमा योजना सब अप्लाई करते हैं आप फिर. Yes, any lapse rate is reduction of temperature. Lapse means reduce, fall. Lapse rate is the rate of falling per kilometer. So NLR is also cooling, and ELR is also cooling, but the rates are different. Okay, NLR, I said, is the hypothetical value for atmosphere at a steady state. ELR is the actual rate of cooling. Okay, a hypothetical rate is in conditions which is ideal, where atmosphere is in balanced state. Okay, so this is not the reality. Okay, but this is the variable. Fine, I'll explain that once again. Why ELR is more in the summers? Because I said, if this is the troposphere, the above layers are cool, the lower layers are warm. Above layer temperature does not increase or decrease much. In the troposphere, the temperature approximately is about 60 degrees centigrade at the outer limits of troposphere, because the height is pretty big. Whatever variations we have, the variations are at the surface level. So let's assume, say this is minus 60. Okay, so in the summers, say in the winters, the temperature surface has say 20 degrees centigrade. In the summers, the temperature is say 40 degrees centigrade. So which is a bigger gap? 20 minus 60 is bigger, or 40 minus 60 is bigger? Okay, so this is bigger amount, right? The difference is more. In this case, the difference is much more. So which rate is more? The summer rate is more. The winter rate is less. The daytime will be more. The nighttime will be less. The summers on the land will be even more. Okay, and on the water will be lesser. So the difference of temperature does not so much depends on this temperature. It depends more on the surface temperature. I hope some of you have got that now. Yeah, Snehashish, that's what I was doing. Anybody else offline? Any doubts offline? Anybody? Any questions? वो क्यों पूछ रहे हो? वो कहाँ से आ गया? Okay. Don't ask what I'll teach afterwards. It's too early. Okay. धीरे-धीरे मारते हैं ना आपको. एक दिन थोड़ी आपको हलाक कर देंगे. Anybody else offline? There's something called as adiabatic lapse rate. We don't need that right now. Afterwards. Summary is going to 2 pages. Rachit, it is more. Try reducing that to within 1 page. In the summary, you must write only the most important word that you think you will forget or you think it's very important. Example I give is, for example, I do not know anything about the capitals of the world. So when I am told India's capital is Delhi, Pakistan is Islamabad, Nepal is Kathmandu, Bangladesh is Dhaka, I'm so amazed, so impressed. यार इतना कुछ जान लिया मैंने और मुझे पता नहीं था. So I write all the capitals name. After couple of months, जब शर्मिंदगी होगी यार इंडिया भी नहीं पता था, I did not know Bangladesh. Okay, so you will remove that and you will say, I know this, I can't forget this. Then you will remember capital of Croatia, capital of Austria, capital of Liechtenstein. वो भूल जाएंगे तब उसको लिखेंगे आप. Your summary sheet is designed according to what you think is very important. You must not forget. Some of you might know ये जो 4 layers of atmosphere सबको पता होगा, तो मत लिखो डिटेल में. Just write down atmosphere, 4 layers, troposphere, stratosphere, mesosphere, thermosphere. I know T troposphere हो सकता है, but some of you have no idea ये T क्या है. T for Tarzan है, okay, T for Tata Group है. So then you must write down troposphere in detail. Okay, so your summary sheet का length depends on your academic proficiency. Okay, and some of it, even if I know it, I'll say, nahi, isko main likhunga. Why? Because I don't want to forget it in the future also. So if your summary is long, ka matlab hai, aap sab kuch likh rahe ho and too much of detail, that tells me the basics are missing in your case. Others, perfectly fine, squeeze it. I mean, you'll come to a stage. Abhi to I'm a bit more generous and liberal now. I mean, before 6-7 years when I used to teach, I was very strict. Your summary of one class should be in about 1/3 of a page. Okay, and we have students doing it. So in time I realized, okay, you have got so much to learn from WhatsApp and YouTube. Okay, so 1/3 page kam ho jata hai. Okay, so I said, okay, I'm liberal now. Take 1 page. Uske upar bargaining na karo कि 2 page ho raha hai, 4 page ho raha hai. Okay, fine. Let's move on. Let me summarize quickly. One doubt I'll take up. What was that? No. All radiations are capable of heating. If the radiations get absorbed, all radiation, because energy hai na, energy when get absorbed, it will heat. Ultraviolet can heat, okay, visible spectrum can heat, infrared can heat, but the heating ability will vary according to the wavelength and frequency. But the heating is only when it is absorbed. If energy is passing and can pass through my body, it won't heat my body. When a body absorbs it, then you will have heating. Or if energy comes and bounces back, it reflects back, even that will not heat my body. So anything, any energy, if absorbed, will be responsible for heating it. Good, Zainab. Okay, fine. So quickly, summarizing yesterday's class, we had some conversation on origin of Earth, of atmosphere. And origin, I said, was in phases. Okay, part of Earth's accretion, okay, part of the volcanism, and part of the biological process. So how did our atmosphere originate? It's a mix of evolutionary process, mechanical process, and biological process. And we have the atmosphere that we have. That was one. The second conversation was on atmospheric composition. The atmosphere is a mixture. Atmosphere has many gases. Along with gases, we also have dust particles, ice crystals, water vapor, salts. We have moisture, okay, and all of that together. But the more important component are the gases. And some gases are the major gases, some are the minor gases. Major gas में हम 2 ही add करते हैं generally, which is nitrogen 78% and oxygen is 21%. Together they make up 99% of the atmosphere. The rest are trace gases, less important in terms of their amount. The argon 0.93, carbon dioxide 0.03, water vapor is variable, oxygen, helium, ozone, krypton and xenon, a lot of gases there. But they're very, very small in traces, but equally important in some other ways. Fine. So now we discuss the significance of the greenhouse gases because they're capable of heating and capable of distributing the energy across the earth. So greenhouse gases are not same as the nitrogen and oxygen. ये दो greenhouse substances नहीं है. That's why we said, while nitrogen, oxygen may be important otherwise, while they may be important for other aspects of our life and atmospheric processes, but what controls atmospheric phenomena, what controls atmospheric events like winds, like rising air, sinking air, rainfall, snowfall, cyclones, we have thunderstorms, we have clouds. So those atmospheric phenomena, the atmospheric processes are because of the greenhouse gases. That's why the atmospheric gases and substances that make up less than 0.1, they are more important than the remaining 99.9% of the atmosphere. In argon does not have any role in terms of atmospheric processes. I hope you appreciate that as a part of atmosphere. The fourth discussion we had was that the atmosphere is arranged in some ways. Arrangement mein, the fact is atmosphere is a mixture, but it is so well mixed for much of the atmosphere. I keep on insisting this word, because atmosphere is just not some layer. Atmosphere is right up to the upper, say, layers as far as 1000 kilometers, as far as 800 kilometers. ये पूरा atmosphere है. But then the atmosphere is not uniformly distributed. For much of the atmosphere, where we have the atmospheric content, the lower parts, for much of this, the atmosphere is very well mixed. Good mixing. There is no molecular weight segregation. There is no segregation in terms of their ionic weight. Okay, the atmosphere behaves like one single gas, a unified gas with some gas laws it obeys. So that's one important insight for us. The atmosphere is a mixture, yet it behaves like one single gas. Okay. Then we said the arrangement of atmosphere is studied in some other ways. Okay. So in this single gas, we say there is no segregation. There is no segregation of layers in terms of molecular weight, but there is segregation and there is layering on the basis of density of the air. Density of molecules के basis पे नहीं है, density of individual gases नहीं है, but density of the air in totality, yes, we have some amount of layering. The lower layers have more air, more packed air. As a rise up, the air is more rarefied. The lower layers have more molecules. As a rise up, the molecules are less in number. The lower layers will have more compaction, more compression. The above layers, the air is more spread out. So we have layering, but layering is on the basis of air density. And this, we said, is because of two reasons. One is air has a weight, and the second is air is compressible. If something is not compressible, if I have some body here, a solid body, it can't compress it. Even if you press too much here, this layer will not have a high density. It will have uniform. Think of a solid iron block, a solid block of metal. Okay, many of them can't be compressed beyond a point. So even if I apply pressure, it's a water property. Water can't be compressed beyond a point. That's why water is used in the hydraulic machines. Okay, which relationships in terms of area and pressure applied, and it's constant across the entire system. So water in general can't be compressed. You can't compress water and make it more dense. There is some, but not too much there. Otherwise, however, we have compression of gases. Because air is a gas, you apply weight, the lower layer gets packed. Okay, and because of this, I gave you this relationship. The density will dramatically reduce as we go up with height. This is 1 atmosphere. By the time I hit 5.6 kilometers, it's half atmosphere, 16 kilometers. Okay, only 10% is left, and so on. The dramatic fall of density with height. And it also parallels the fall of atmospheric pressure with height. You rise up, it becomes more and more, less pressure. Yes, Dimanshu, correct. How we differentiate between atmospheric process and climatic process? Dhananjay, same thing. Climatic process is same as atmospheric process. Okay, atmosphere is operating to make a climate. Climate is a condition. It's because of the atmosphere behaving in some ways. So they're not really two different words. Okay, so that's about this one. Then I very superficially, where we have good mixing, that is homosphere. Where we have less mixing, we have heterosphere. Okay, that is gone. But the more important discussion was on the layering on the basis of temperature trends. Okay, the rate of cooling, the rate of warming. Okay, what is responsible for the temperature? So on the basis of temperature trends, we have layering of the atmosphere. Okay, so in this I said that gamma rays don't play a role, X-rays don't play a role, microwaves don't play a role, radio don't play a role. The main energy coming inside is ultraviolet, infrared, and the visible spectrum. And the infrared is significant amount, Okay, but ultimately what happens is, okay, your ultraviolet gets absorbed, visible and infrared passes through and absorbed by the Earth's at surface. And then you have got re-radiation. The re-radiation is responsible for warming of the lower layers. So आपके जो layers हैं, the uppermost layer, because it has ions, so this is warm, you come down, it will become cold. Like this is warm layer, so more heat is absorbed here, you come down, less heat is absorbed, so it is warm here, it is cool here. Stratosphere, same thing. Okay, it comes down, you've got ozone layers. Ozone will block here. So more ozone here, it will absorb, it becomes warm. Away from this, it will now also become cool. In case of troposphere, energy goes like this. This part is warm. You rise up, it becomes cold. Basically, it becomes cooler away from the source of the heat. The main heat, okay, warming is here, it becomes cooler as you come down. Main warm is here, it cooler is come down. In this case, it becomes cooler when it rises up. Okay, so this is the rate of cooling, this is the rate of warming, and this is the rate of warming. So thermosphere is warm above, cold below. Troposphere is warm above, stratosphere, warm above, cold below, and troposphere is cold above and warm below. Okay. Now mesosphere, some of you had a question here. So what my question to you is, if this layer, say this cool, let me imagine some numbers, okay? This is say minus 90 is the temperature here, and this temperature is at around 2 degrees centigrade. तो आप बताओ कूलिंग कहां से होगा? वार्मिंग नीचे से होगा कि ऊपर से होगा? If this temperature we know is minus 90, this we know is 2 degrees centigrade, this we know is approximately minus 60. Okay, the surface approximately is 15 degrees centigrade. So how will the warming or cooling happen? Okay, so in this case, because this is 2 at a higher temperature and this lower, so the lower layers in contact are warmer. You rise up, it will become cold. So the trend will look like this. Mesosphere is like a transition layer. Yeah, I think that's okay now, all of you. So some of you had a problem in imagining why these lines are there. Why CO2 is transparent? Now see, why some gases can't absorb or why some gases can absorb, that is a function of the gas property. वो gas का property ऐसा है that it can't absorb radiations at certain range of wavelength. The gas has a property, it can absorb only in so and so. It's like, you are throwing say football at me. Okay, it is my property at what speed I can catch it. It's my skill, it's my ability. Okay, so I can only catch at certain speed, remaining I can't hold, it'll pass by. So absorption capacity of heat by a gas is a function of the gas property. So why? Because that is how CO2 is. This cancer, why does water flow? Why is oxygen supports combustion? Why is hydrogen lighter? That's a property. We just simply accept that. Temperature trend. What is that, Aman? Why are you using these words? What do you mean by dynamically created? क्या मतलब है आपका? कुछ words आप use कर लेते हो, then I am confused for the rest of the time. Okay. Why are you using the word dynamic? इसमें dynamic क्या है? Okay. Okay, think and tell me what you asked me. Anybody else here? You know the layers, all of you now? The 4 layers, and you can add this values, okay? Troposphere boundary is minus 60. Stratosphere boundary is about 2 degrees centigrade. The mesosphere is around minus 90, and ऊपर वाला आप छोड़ दें. It imperceptibly merges with the outer space. The exosphere is the outer layers. Okay, so when I talk in terms of location, कहाँ पर है, the outer layers are called as exosphere. But in temperature terms, so the problem is, okay, think, देखो, layering in terms of temperature layering in terms of a relative mixing, layering in terms of a location or height. ये तीन अलग concepts है ना. Okay, say who am I depends on what role I perform, depends on what I am doing, depends on what my education is, depends on what language I speak, depends on what country I was born in. Okay, the same thing can be different ways. So I am an Indian, at the same time, okay, I am a teacher, at the same time, probably I like traveling, at the same time, maybe I have some other interests. These two are not concepts which are confusing. Why? Because the alag-alag roles hain. So when I say layering in terms of temperature, then I will only use troposphere, stratosphere, mesosphere, and thermosphere. That's all. In terms of mixing, I will say this is heterosphere, this is the homosphere. In terms of location, I will say this is lower atmosphere, this is mid atmosphere, and this is a higher atmosphere. I can call this as the exosphere. So don't say thermosphere is equal to exosphere. Okay, we just know that when I talk in terms of temperature, फिर हम यही term use करेंगे. Exosphere क्या है? Exosphere is the outer margins of atmosphere. So yes, तो thermosphere ही बन जाएगा exosphere, right? But don't say, can I call thermosphere as exosphere? Okay, no, that's the wrong way of comparing. So similarly, if I talk in terms of composition, then I'll say there's a layer called as ionosphere, the layer called as ozone layer. Okay, so ionosphere is not same as thermosphere, although they coincide. But when I use the term ionosphere, I'll say it's a layer which has ions. Okay? So Rahul, ionosphere starts after 80 kilometers. That's all. So ionosphere also becomes the thermosphere. Ionosphere also becomes your heterosphere. Okay? Yes. Between wavelength size of particles. साइज से बात नहीं करेंगे. वेवलेंथ एनर्जी का होता है, पार्टिकल्स का नहीं. There are some laws in that. There are Hallen scattering, Mie scattering. So what happens to a body? If there's a body here, energy is coming. Can the energy bounce back? Can the energy turn and go? Can the energy strike and break up? That depends on kitna bada particles hai. So scattering is one phenomena, where energy can split up. There are some size in which it happens. So that size will give you different type of scattering phenomena. The most common one we talk about is Mie scattering, M-I-E scattering. Okay? That's all, leave it at that. You don't have to enter into what are the mechanisms. So it's hardcore, say optics padna shuru ho jayega phir aapka. Just know, yes, you're right. What happens to energy depends on what type of particles it is moving through. So kuch dimension ke size mein, some wavelength, not all wavelengths, some wavelengths will start scatter. Uske laws hai. Ignore that for now. What is in third table? I talk in terms, this is in terms of relative mixing, heterosphere and homosphere. This is in terms of location, it's in terms of height, kitne ऊंचाई पे है. So lower atmosphere, mid atmosphere, upper atmosphere, and outer atmosphere. Which air will have I think moist air will have more. Moist air will have more. Okay. Let's move on. Any questions on the layering, anybody? So a couple of facts now. So you can talk about miscellaneous facts about the Earth's atmosphere. Facts about atmosphere. So number one is like a summary of whatever I've told you. Number one is that much of the atmospheric processes are because of greenhouse gases in the troposphere. Much of the atmospheric processes are because of greenhouse gases in the troposphere. You know this now. Carbon dioxide, water vapor, dust particles, okay, and aerosols, they are the main, plus methane. They are the greenhouse gases or substances in the blue atmosphere. One. Number two, the height of troposphere varies. The height of troposphere varies. It is at around 4 to 6 kilometers above the poles. It is about 4 to 6 kilometers above the poles, and at about 16 to 18 kilometers at the equator. ये भी vary करेगा, you know, some seasons में it can also be 8 kilometers at the poles. So know the range, 4, 5, 6, 7, approximately at the poles, 16 kilometers, sometimes 20 kilometers, on an average about 16, 18 kilometers above the equator. And this variation is because of the strong convections, convection or strong rising of air at the equator. Strong rising of air at the equator. So you should imagine the upper height of troposphere is like a lid, Dhakkan lid. So if there is more convection, more rising air, this will get pushed above like this. And this part, this cold air will sink. Okay, it'll come down. So your troposphere, okay, imagine the outer margins like a lid. Okay, if you have got strong rising air, okay, this will get pushed above, and this cold air will sink. It will get pushed below. So ultimately, your troposphere is like this. Okay. So the question now I ask you is, if on an average, the surface temperature of Earth is around 10 or 15 degrees centigrade, where will we have less temperature? Will we have less temperature above the poles here, or will we have less temperature above equator here? Kahan hoga less temperature? Okay, did you get the idea, all of you? Why? On one hand, I'm saying the warm air is rising. Warm air is rising, so some of you will assume, sir, ye warm air rise karke to yahan pahunch gaya, to yahan par to warm hona chahiye. Again, this is cold and this is sinking below. Okay, so probably this area should be, I'm comparing temperature at the upper parts above equator and above the poles, which will be cooler. So remember this for now, at least. This warm air rising does not rise up to here. Okay, it pushes, iska rise bahut kam tak hota hai. Okay, but this push is capable of pushing it upwards. So the temperature here is not because of the warm air rising. It is because of this 15-degree lapse rate in terms of height. This will be approximately 15. Okay, minus, if I take NLR, for example, minus the height is say 18 into 6.4. I hope you got the point here. So the height is 18 kilometers, 6.4 per kilometer. For 18 kilometers, 18, 6.4. And here it will be, say, if not 15, it will be, say, 0 maybe. 0 minus, it is 6 kilometers into 6.4. So temperature here, lapse rate, this is a 6.4 centigrade less high temperature every kilometer. So ultimately what we'll have is the temperature here is lesser than temperature here. So some of you know this, maybe by heart you understand this, but remember this, that in the upper troposphere, okay, at the equator, the temperatures are lesser. At the upper troposphere or in the upper troposphere at the equator, the temperatures are lesser than at the poles. Correct, right, Nikita? Than at the poles. Why? Because the height is more. So with height, the cooling becomes more. Lapse rate apply karoge aap. Okay, but otherwise, on average, this is about minus 60 degrees centigrade. That's one. Second, next point is the troposphere, because of greenhouse gases, is capable of mixing, and hence has all the weather phenomena. Okay, so what happens is, now watch here all of you. In which case will air rise and in which case air will sink? When lower layers are warm, upper layers are cold. Lower layers are cold, upper layers are warm. In which case will air rise? When the lower layers are warm, warm air will expand, will become lighter, will start rising. And if the lower layers are cold, kya hoga? Air will settle down. So when I'm looking at mixing of the air, the mixing happens when the lower layers are warm. It will rise up, hit the upper layers and start mixing here. So the troposphere mein, you have all the mixing going on. That's why this is the weather layer. The word tropo means turning. Kuch mix ho raha hai. Okay, it's turning. This was a question asked in your GS paper. Why is the troposphere the weather layer? Because the troposphere has greenhouse substances. The troposphere has a lapse rate, the vertical movements of air. Therefore, we have troposphere as the weather layer. The continuous mixing going on in the troposphere. All fine here? So, likh lijiye aapne wala point. That the troposphere, therefore, is the weather layer. It is the constantly mixing layer. Okay. But in stratosphere, we don't have this. In stratosphere, what happens? The lower layers are cold, the above layers are warm. It's a mixing nahi hone wala. That's why the stratosphere mein, the layers kind of segregate out. Okay, so that's why it's called as stratosphere, as in strata. There are different layers. The layers will go if you mix it. Okay, when stratosphere, there's no mixing going on. That's why stratosphere, the layers become a bit more distinct. You know, the stratosphere is the most stable layer. Because it does not mix. How are clouds formed? Water vapor hai. Okay, the air will rise, will become cold and will become clouds. So if air is not rising, will I have clouds? So where will we have clouds? Clouds in the troposphere or stratosphere? So stratosphere largely has no clouds. You know, clouds formation and the winds are largely a phenomena of the troposphere. Clouds formation, the winds are largely the phenomena of the troposphere. Whereas the stratosphere will not have clouds. Will not have the clouds. This is in general. In general, stratosphere clouds. But what happens is, because of chemical reactions, because of some processes, some moisture can escape into in the stratosphere, and then they can become some clouds. But those clouds will not cause rains. Okay. So in general, I said, In general, I said the stratosphere has no clouds in general, but because of chemical reactions, because of some whatever process, even I do not know much about it, there may be some clouds. Some clouds. These clouds are called as nacreous clouds, and nacreous clouds, they don't cause rains. Necro means dead. Okay. So the clouds of stratosphere, thoda bahut hote hain sometimes, they are dead clouds. They don't cause rains. They are nacreous clouds. In general, otherwise, we'll say stratosphere has no clouds. That's one fact. Another fact, the mesosphere can also have some clouds. The mesosphere can also have some clouds, but not significant in terms of rainfall. But not significant in terms of rainfall. It's a alag type ke hain, chemical composition. I do not know much about it. But the mesosphere clouds are called as noctilucent clouds. They're called as noctilucent. Nocturnal, night. Lucent means they start to glow. These clouds, night time, they can look a bit bright. They're called as noctilucent clouds. They glow in the night time. They are mesospheric clouds, but not like the clouds that we know of in the troposphere. That's one fact. Another fact. Now look at this. Example I always give is, imagine I have a ball in my hand, a stone in my hand, and I throw it. I think basic physics we know, as the ball rises up, it will become slow, it will become slow, it will become slow. At some point, almost stationary, zero velocity, and then start falling. So if you have this as troposphere and this as stratosphere, the temperature becomes less, becomes less, becomes less, becomes less, becomes less, and then it starts to increase. It's increasing, it's increasing. I'm not saying temperature becomes zero. I'm just saying the fall is happening, okay, and then it's increasing. If a transition hoga, there is one layer here, where the fall of temperature stops. Okay, it's like I'm getting random numbers here. So this is 20 centigrade. It becomes colder, it becomes 15. It becomes colder, it becomes maybe 0. Becomes colder, it becomes minus 10. Becomes minus 20. It becomes minus 40. It stays minus 40, minus 40, minus 40, and then starts warming. Minus 30, minus 20, 0, 10, 15, and so on. So there is one layer here where the fall. So if you look at the graph here, okay, this is falling, this is falling, this is falling. There is no fall. It's a vertical line. And then it starts increasing. Can you all imagine this, all of you? There is a transition layer where the temperatures remain constant, because on this graph, I am plotting temperature. Okay, this is zero, this is not zero, some other value. So this is 10, this is probably 5 and 0 and so on. So at some height, the temperature remains constant and then starts to increase. So this transition layer, where temperature doesn't fall or increase, it's called as isothermal layers. Isothermal as in same temperature. And these isothermal layers have different names. So har layer mein aise hoga. This is the troposphere isothermal. Then we have the stratosphere ka isothermal. Okay. And then we will have the mesosphere isothermal. And then we have the thermosphere. So in all the cases, fall remains constant, increase remains constant, again fall remains constant, and again increase. So this isothermal layer of upper troposphere, this is isothermal a thermal layer of upper stratosphere. This is thermal layer of upper mesosphere. Okay. Isothermal means the temperature are constant. Iso means same. Isosceles triangle. Isotherms. Iso height. Iso bar. Iso means something remaining same. Okay. Isothermal layers of upper troposphere. Isothermal of upper stratosphere. Isothermal of above mesosphere. इसके names हैं. Because the temperature starts to remain same. The fall stops. We call this as the tropopause. Pause का मतलब क्या हुआ? Something has stopped. What has stopped? Temperature fall has stopped. So tropopause. This is called as the stratopause. And this is called as the mesopause. So a mesopause, average temperature is minus 90. This is about 2 degrees centigrade. And this is about minus 60 degrees centigrade. All fine? These are transition layers between the thermal layers of the atmosphere. Can I move on now? Okay, fine. The next fact. Now see, if I go by the troposphere as a trend, then I say the troposphere will cool with height. Anything which is not cooling with height is called as inversion. Okay, I must go up, it must cool. अगर cool नहीं होके constant हो गया, अगर cool नहीं होके warming हो गया, I call that as temperature inversion. Something has got inverted. What has got inverted? The lapse rate has got inverted. It must cool, it remains constant. It must cool, it is now warming. I hope you got the point here. So, write down this point here. Temperature inversion is a phenomena. Temperature inversion is a phenomena where the lapse rate becomes zero. The lapse rate becomes zero, or the lapse rate inverts. That is the atmosphere starts warming with height. Temperature inversion is a phenomena where the lapse rate stops. Lapse becomes zero का मतलब क्या है? There's no cooling anymore. Like it stops, or the lapse rate inverts. Inverts means, or reverses means, the temperature starts warming with height. Is it okay, all of you? Therefore, these are examples of temperature inversion. The tropopause, the stratosphere, okay, the stratopause, okay, the mesopause, and the thermosphere. The examples of temperature inversions. Therefore, the isothermal layers, comma, that stratospheric layer, the isothermal layers, the stratospheric layers, and the thermosphere are examples of temperature inversion. Okay. And I told this to all of you, I mean, at a very high level, of course. When does air rise? Air rises when the lower layers are warmer compared to the above layers. Then we rise karega, right? If the temperatures are same, will the air rise? Okay. Will the air rise? No, it will not. If temperatures become, okay, cold with height, will it rise? Sorry, warm with height, will it rise? Again, no. Okay. So why in the troposphere, air rises because lower layer warm, upper layer cold is rising and it is mixing. Okay. Will the air rise here? No. Can the air rise here? No. Will the air rise inside this also? Again, no. So whenever we have inversion, it will stop the vertical rise of air. That's why the tropopause acts like a lid. ये allow नहीं करेगा for the air to rise beyond this. So air is rising, it hits the tropopause, will stop here. And the air will again turn like this and will start to sink here. So the inversion layers will inhibit vertical mixing of airs. Write down. The inversion layers will inhibit, will block, will inhibit the vertical mixing of the layers. That's why the tropopause, therefore the tropopause is responsible for, trapping all weather phenomena inside the troposphere. Responsible for trapping all weather phenomena inside the troposphere. Is it okay, all of you here? This was a question asked in GS. Why is troposphere the weather layer? Iska 3 reasons hai. One is the troposphere is heated from below. The troposphere has the greenhouse gases. Okay, plus there is a tropopause which blocks the vertical movement beyond this. So whatever mixing we have only inside the troposphere. The inversion layers, they act like a lid. They act like a cover, and the air can't escape the cover. It all gets trapped inside, okay, and we have all the weather phenomena. It'll block because air can't cross it. Okay, air will cross only when there is some temperature difference. The lower layers are warm, the upper layers are cold. Fir wo rise karega. If there's no temperature difference, there's no gradient. For any movement, I need a gradient. And this gradient agar nahi hai, like in isothermal space, then the air will get blocked here. Satyam, वही तो बता रहे थे आपको. Why is this forming? Question all of you. Why has this formed? यहाँ क्यों बन रहा है? Anybody? Why is this forming? Because ozone is here and not here. Okay, this area has ozone, can trap the heat coming inside. यहाँ पर ozone नहीं है. यहाँ पर heating is only possible from below. That's why. Why is this formed? This has ions. It can get warm. It has nothing of that kind here. That's how we started off the conversation, no? Troposphere is a weather layer because all the weather phenomena, all mixing is trapped inside the layer. And what traps it? The inversion layers traps it. The tropopause acts like a lid. It will not allow for the air to go beyond this. Whatever air we have will keep on moving inside this. So tropopause becomes the weather layer. Likely, aap loग all done? Okay, fine. Let's move on. The next is beyond 80 kilometers. Beyond 80 kilometers. 80 kilometers is the height of the mesosphere. Okay, this is you know the height here. This is about 50 kilometers, and this is 80 kilometers. Beyond 80 kilometers is the thermosphere. The thermosphere, which has ions, and can absorb ultraviolet radiations. It has ions and it can absorb ultraviolet radiations. It has very high temperatures because it absorbs kar raha hai heat. It has very high temperatures. Thermosphere mein zyada temperature hoga. It is absorbing ultraviolet. It has very high temperatures, but it has very less heat. Very high temperatures, but very less heat. Can you appreciate this, all of you? What is temperature and what is heat? Temperature is the measure of hotness or coldness. Kitna garam hai. Temperature is not same as heat. Heat is energy. Heat is equal to the formula mc theta. Mass, specific heat, and difference of temperature is heat. Okay, so temperature theta is very, very high, but thermosphere does not have much molecules. The mass is almost zero here. Can you all imagine this here? Okay, so the thermosphere has very high temperatures. If you have a thermometer, it'll record a very high temperature, but the heat is not much. Okay, the heat is very less. Why? Because the thermosphere has very negligible mass. Head down. Because thermosphere has very negligible mass. टेम्परेचर हीट नहीं आ रहा है, कहां से आना चाहिए था बताओ? ओके फाइन. सो कब तक पढ़ाई से भागते बताओ? सो यू हैव okay 1 kg of water and you have a rod which probably is 1 kg. And you are heating it. You are heating it here. You are heating it here. Which will become hot faster? The water will become hot faster, or this will become hot faster? This is iron. Okay. So what happens is iron, because it's a good conductor and some specific heat here, small amount of heat also becomes very. आप पकड़ नहीं पाओगे उसको. Water can keep adding heat for a long, long time. Okay, but it will not feel warm too much. So it's possible for some substance to absorb more heat, yet it will not be as hot. Some substances can absorb less heat and can become very hot. So heat and temperatures are not the same things. The very basic thing. Water has very high specific heat capacity. No, not latent heat. Don't go there. हम अभी evaporation की बात ही नहीं कर रहे हैं. Okay. I'm talking about the water itself, same state here. So heat and temperatures are not the same things. That's one problem that we have in assumption. So heat is energy. Okay, energy depends on mass and also temperature. इसीलिए मैंने formula दे दिया आपको. There's mass, a specific heat, and a temperature. I can have a body which has very high temperature and almost zero mass. The heat will not be much. I can have a body where the specific heat is very, very high. It'll take a lot of heat, energy to become hot. So these are different combinations possible. So for now, I think you remember this. The thermosphere has high temperature, okay, because it absorbs ultraviolet, but it doesn't have much heat. Why? Because it has almost negligible mass. ऊपर molecules ही नहीं है. So how do we have too much of heat? The mass is a factor. Okay, let's move on. The next point. The next point here. The ionosphere layer. The ionosphere layer is capable of reflecting radio communication waves. Is capable of reflecting radio communication waves. So ionosphere अपने आप में अलग अलग layers हैं. Head down. The lowermost layer, the lowermost ionosphere layer is called as Kennelly heavy side layer. Okay, Kennelly heavy side layer. Okay, the lowermost. If this is the ionosphere, there are a lot of layers here. The lower layer, फिर D layer है, फिर एक E layer है, फिर F layer है, D dash, a lot of layers are there. Forget about all the names here. Just know the lower layer is called as Kennelly heavy side layer. The above layer is called as Appleton layer. Appleton layer. The Appleton layer can reflect shortwave radio waves. The Appleton layer can reflect short radio waves. and this one can reflect medium radio waves. Medium radio waves, and this can reflect short radio waves. Don't say short waves. Short waves kuch aur meaning ho jaye. It's short radio waves hain in terms of wavelength. Kennelly Heaviside can reflect medium waves, okay, medium radio waves, and the Appleton layer can reflect, okay, short radio waves. So it's essentially the Earth here. Okay, this is the thermosphere. Okay, and this has some layers. This has some layers. So there's a transmitter here. It can transmit, bounce back from here, and we can have a receiver here. That's how a radio communication happens. The radio happens because of reflection from the ionosphere. The Appleton layer is the above layer. Yes, Pradeep. A short wave, medium wave, all are about the wavelengths. The above layer is Appleton layer. The lower layer is the many more layers. D layer hai, D sporadic layer hai, D dash layer hai, E layer hai. Ignore all of that. Just know this much. Take it all done here. Some facts about the atmosphere here. Okay. And last point, likho aap. Right, last point I down. Okay. Atmosphere. The atmosphere is a dynamic layer. The atmosphere is a dynamic layer. It performs a very important function. It performs a very important function of protecting the earth from harmful radiations, and also protects earth from space rocks and meteors. Space rocks and meteors. METEORS. So atmosphere, okay, it will burn away the rocks. The rocks come inside, because of friction they can burn away. And you can see that as a shooting star. These three terms, I presume you should know. What is a meteoroid? What is a meteor? And what is a meteorite? Earth here, atmosphere here, those rocks and stones which are in the outer space. They're in the outer space. They're called as meteorites. When they enter atmosphere and while moving, they burn off like a streak of light. They burn off like a streak of light. Shooting star jo bolte hain. That is a meteor. This is a meteor. It is a shooting star. And some of them, they enter and they strike the Earth's surface. This one is called as the meteor. It's called as the meteorite. This impact can create craters and whatever. All good here? Asteroids are much, much bigger. Asteroids are between, okay, and beyond the Mars belt. आप उसको छोड़ दीजिए अभी आप. I'm talking about other random rocks. They're called as, okay, meteoroids. Asteroids are much larger. Okay, let's move on. Yes. जिसमें T लगा है. This is terrestrial. This is Earth. Okay, जिसमें D लगा है. Okay, don't know. तो ये बाहरी हो सकता है. और इसमें कुछ लगा नहीं, अंदर आता तो है बस जल जाता है. Is it okay now? Okay. So the one with T will hit the Earth. The one with D remains outside. Okay. Whatever remains is in between or here. Find your ways of remembering things. Okay, but har jagah don't try to do this. You only have series of cues, but concept pata nahi hai. Okay, I'm done with atmosphere. Okay, nothing beyond this for now. Take up a fresh page. We study the next concept called as the heat budget. The next concept called as the heat budget. These topics, there are no questions till now directly on these. There was one question, I think, way back in early 90s. The question was, discuss the structure and composition of the atmosphere. Okay, but 90s may understandable. Now the concepts have gone much deeper. No point asking those questions anymore. Okay, let's start off with heat budget. Now, what is a budget? Budget is a statement of comparison. What comes in, what goes out. In any natural process, there is some type of a balance. And the balance is what maintains our life, our planets. It maintains whatever we have around us. There's a balance of life, balance of water, the balance of oxygen, balance of nitrogen, balance of how the crust forms and gets destroyed. Sab kuch nature makes harmony and balance. Now this balance, we can study in two ways. I can study the balance in terms of a cycle. Something is cycling. Water is there, water evaporates, goes up, clouds formation, rainfall, it comes down, again evaporates. This is a cyclic concept telling me about how water circulates. The same I can do for oxygen. There's oxygen formation, it is breathed in, metabolism, it again gets released, it again gets breathed in, photosynthesis, and you can go on there. So oxygen also kind of recycles. Carbon also cycles. There are rocks in cycle, carbon in life forms, they die off, they have respiration, some is emission like methane, atmosphere, then the plants again absorb it, again they release, and this is the carbon cycle. Where say we have got nitrogen cycle, sulfur cycle, rock cycle, we have crustal cycles. Continents and oceans can also in some way cycle. So cycle is a word that tells us something is happening to maintain the balance. Cycle is a pictorial depiction of how things are changing. Cycle is a type of a visual depiction. As a born, you are growing, you mature, become adult, you become old, you die, and karma gets back again, and you again are born as a butterfly. Some of your lucky ones probably become some better human beings and so on. The cycle jo concept hai, it is a visual concept. There's one more way of studying how things happen. That's a mathematical way of doing. X comes in, X goes out. 10 comes in, 10 goes out. So when I study the cyclical thing in terms of a chemical equation, in terms of a mathematical equation, in terms of a numerical equation, I call that as a budget. Have we got the point here? So in our economic systems also, we have monetary cycles, no? Monetary cycles, somebody makes the money, somebody spends the money, somebody earns the money gets transferred, you take loans. So I have got a visual depiction of how money flows. We have got monetary flow systems, and we have got fiscal flow systems. That's a visual depiction. The same thing I can talk in terms of a equation, a table. X amount comes in, that is my revenue. X amount goes out, that is my expenditure. And I do the balancing, and that's what is my deficit or surplus or whatever. So any budget is a mathematical, it is a numerical a way of appreciating how any balance is maintained or not. It's a mathematical way. It is a numerical way of appreciating how balance is maintained or not. If more comes in, less goes out, I've got a surplus budget. If less comes in, more goes out, I have got a deficit budget. Is it okay, all of you? Is it fine, all of you? So when I talk about the Earth and Earth's heat concept, I talk about the heat budget. So what's heat budget? Heat budget, right down here. Heat budget is okay, a mathematical analysis of how energy enters the Earth atmosphere system, how energy enters the Earth atmosphere system, and how energy transforms, energy gets transferred, how energy transforms, how energy gets transferred and finally lost from the Earth atmosphere system. How energy comes in, how energy transforms, how energy is transferred, and finally how energy is lost from the Earth atmosphere system. And we do this in a mathematical way. So I will have a table. I'll say this is the incoming energy, XYZ. This is the outgoing energy, XYZ. And then I'll find a balance, ki equal hai ya nahi hai, or whatever happens. Is it okay, all of you? Now, the purpose of lost from Earth atmosphere system. There is Earth, there is Sun, there's Earth and atmosphere. How does energy come in? How energy moves, how energy transforms, and how ultimately energy is also lost. So I do this mathematical thing, I call that as heat budget. Now the question is, why do I need to study this? Because see, I said fundamentally, the atmospheric processes are because of the energy imbalance, no? Why do winds move? Something is hot, something is cold, winds will start moving. Why do we have clouds formation? Something is warm, it rises, becomes cold, and becomes clouds. So any movement we have is because of different energy. Now I'm curious now. In that case, tell me, how is energy coming in? How is it moving out? Because fundamentally, again, the appreciation is, then all of these energy mechanisms, Earth is constantly receiving energy, right? Ever since Earth was born, ever since Earth exists, Earth has received energy incessantly. But has Earth become warm and exploded? No. Earth is maintaining its ambient temperature. Yes, you and I and our activities are disrupting all of that. But otherwise, Earth has fairly maintained its temperature. Around 15 degrees centigrade is the ambient temperature. जब ice age भी होता है, it falls by 3/4 centigrade. A global warming भी है. Our average is how much? Increased by 1.5 or 2 degrees centigrade, correct? Why though average will roast us. So Earth more or less is a mechanism of maintaining the numbers. The question is, how does it do it? What are the processes? What are the components involved? So Earth is receiving energy, but Earth does not become progressively hot. There's some mechanism by which energy comes in and also energy is lost. Tell us how that happens. Take all of you? Okay, fine. Write down here. Write down. A heat budget is a way of appreciating. Heat budget study is a way of appreciating how Earth maintains its energy balance. How Earth maintains its energy balance and does not become progressively hotter or progressively cooler with time. It does not become progressively hotter and progressively cooler with time. Earth has a system of balance. Earth is like a self-regulating system. Agar hot hoga, it will become hot for some time. Something will happen. Again, the cooling will start. Something will happen. Again, the warming will start. The Earth is a kind of what we call as heat engine. Heat engine is something that absorbs energy, does work, and releases energy. The Earth behaves like a heat engine. Earth behaves like an efficient system. So by that logic, ये जो narrative है, global warming is dangerous for Earth. It's not. Okay, it is dangerous for you and I. Earth will survive. Earth has seen ice age. Earth has seen volcanism. Earth has seen no atmosphere. Earth has seen no life. Earth was a nebula. Danger आप और हम है. We will go dinosaur way. Earth will survive. ये जो कहावत है staying, no, Earth will become warm. It will ultimately become cold. Ultimately means 200-300 million years. If you can survive, perfectly fine. Okay, you can look at the Earth also cooling. Okay, but tab tak what happens I do not know. I hope you got the point here. So this heat budget का purpose क्या है? Why are we studying that? This helps appreciate how the Earth manages its energy, how energy moves, what absorbs, what releases, what's responsible for warming, cooling, and so on. Earth's energy is increasing recently. Increase भी कितना आपने चेक कर दिया? Okay, आपने सारा fight मार के you are talking about controlling temperatures within 2 degrees centigrade. Okay, you want it within 1.5 degrees centigrade. On average, अभी about 1 बढ़ा है. Global geological average में 1 has no significance, no? You and I have a problem. Okay, we become uncomfortable and we start dying. Otherwise, average Earth has maintained. Ice age maybe, the average fall is just about 3 or 4 degrees centigrade. That's all. 15 बन जाता है 12. It's an ice age. 15 बन गया 16. You and I get roasted. We are tandoori then. Okay. So, nature tells you, okay, how things can change with slight variations. On average, Earth maintains its temperature. Okay, let's move on. Next point. Earth behaves like an efficient heat engine. Earth behaves like an efficient heat engine. It absorbs energy. And also releases energy. It absorbs energy and it also releases energy. Maintaining its averages. Okay? Some discussions I have seen that they call Earth as a black body. It's a physics term. What's a black body? Black body is any body which can absorb energy, okay, and release entire energy. It will not retain forever. No, not a black hole. Black hole is कुछ भी black हो जाएगा क्या? Okay, black box, black hole, black body. Okay, so it's not the same thing. Black body is a substance, okay, which can absorb heat or energy and can release energy. A black hole अलग concept है, gravity and all of that. Okay, don't go there. Okay? So Earth is like an efficient heat engine. Earth is like an efficient black body. That's why we start off. So now all of you listen to this. Then I'll give you the notes on this. It releases all the energy. Some of it immediately, some takes time, some takes a bit more time. A bit more time could be 100 million years. Ultimately, Earth will release. Okay? Yes, Earth acts as both a heat sink and a heat source also. It can absorb heat, it can also release heat. Okay, so it releases all energy, but there's a time lag. Time lag, short term or long term, but Earth will not retain for, otherwise Earth will become progressively more and more warmer. It will explode then. Yes, okay, let's move on. So we have first the incoming energy, the study of the energy influx. The solar energy is the primary source. Solar energy is more than 99.99% of all energy. और जो थोड़ा बहुत बाकी है, they are from interiors of Earth, tectonic energy. In terms of sun, it is negligible. The sun is the source of the all energy. It's the primary source, almost 99% of all energy. Okay. On average, the solar energy that the Earth receives, receives is approximately about 1.99 calories per centimeter square per minute. Like this amount of energy the Earth receives is approximately equal to 1340 watt per meter square. This amount of energy, okay, Earth receives, okay, 1.99 calories per cm square per minute. Okay, or in terms of, okay, your calories, it is 1340 watt, not calorie, watt per meter square per minute. Okay, now this figure is called as a solar constant. It's called as the solar constant. Okay, there are some variations, maybe because of sunspot cycle or because of some other reasons, but average में हम इतना ही रखते हैं. Okay, and this number, this 1.99 calories per cm square, इसको हम Langley भी बोलते हैं. It's also called as, okay, 1.99 Langley per minute. Langley. Same thing. 1.99 calories per cm square is same as. This is also called as Langley. Langley. Langley per minute is the solar constant. Okay? In some books, your 1.99 you can approximate as 2 Langleys per minute or 2 calories per cm square per minute. Okay, that's no problem. Now, what happens is, if this is the outer atmosphere हम मानते हैं approximately around 800 kilometers is the outer atmosphere. This energy coming in, okay, at outer atmosphere is 2 Langleys per minute, and I can assume this to be 100 units. For our convenience, let's assume the energy coming into the Earth atmosphere system is about 100 units. इसको हम 100 मान के चलते हैं, and this is the Earth's surface. Now this 100 में क्या होता है? What all happens because 100? All keeping pace, all of you? Okay, सुन लो पहले, then I'll give you this points again. So this 100, what happens is, some amount of energy, it enters and it reflects back. It enters, hits the Earth's surface and reflects back. Some of it hits the dust particles, scattering, ultimately is lost. So some amount of energy is reflected. जो reflected component है, we call that as albedo. Albedo means reflection. There is Earth surface albedo, there is clouds albedo, and dust particles albedo. This is the clouds. And this albedo is approximately about 35 units. I am rounding off the numbers ताकि हमें याद रहे, because these numbers will vary. In some books they'll write down 37, 38, 43, 32. Okay, I'll keep it round, nice numbers, so that and you can remember and write about it. Okay, that variations will take care. Okay, so if 100 units are coming in at outer atmosphere, what bounces back is 35. And remember, 35 is the Earth atmosphere albedo. Some of it from the Earth's surface, some from the dust particles, some from the clouds, some mila ke 35 albedo. That's one component. The second component of the energy coming inside, it comes in and it gets absorbed. Absorbed. What absorbs this? The thermosphere ions absorb it. What absorbs this? The ozone of stratosphere absorbs it. This is the ultraviolet component. This absorption is approximately about 15 units. This is absorbed. This is absorbed energy. So 35 is bouncing back, 15 is absorbed, and the remaining energy, okay, it comes in and it is absorbed by the Earth's surface. 15, 35, 50. What remains is 50 here. 50 is absorbed by the Earth's surface. Earth's surface का मतलब है oceans and the continents. You're fine? So what is the details of influx? So influx is equal to 100. Is 100. Breakup is 35 is the total albedo. 15 is absorption. Absorption. किसका absorption है? This is ultraviolet and short wave absorption. And 50 is absorbed. Absorbed by the Earth's surface. So कुल मिला के this also is 100. All fine here? That's how it breaks up. Now don't ask why this number. This is what it is. You just remember it. That's how the Earth behaves. And remember, is absorption hai of the Earth's surface. This entirely is or largely is the visible spectrum. This is the visible spectrum of energy. Energy comes in as infrared, it comes in ultraviolet, it comes in as visible spectrum. The visible spectrum, because all else is lost, visible spectrum hits largely. Though we also have IR, but we'll take care of visible spectrum for now. All fine? Units, I'm taking 100 as a general number. The percentage, I think no problem here. 15 is absorbed by the ozone and the ionosphere. Ozone and the thermosphere is absorbed here. So now write this down, please. So you could draw a table like this. If I've not done it, I'm giving you time for this. I'll read out for all of you. So this is your incoming energy and influx. Incoming influx. The solar energy is the primary energy. And this is 99.9% and more energy. The energy coming in is called as solar constant, almost constant for the Earth. And we assume this to be 100. It's about 1.99 calories per cm square per minute, also called as 1.99 Langley's per minute. This is a quick description here. All done here? Online, are you all done? All done? Yes. So now I'm saying, how does energy break up? Break up mein, number one component is albedo. 15 is albedo. 15 is the reflection. Reflection of the energy from the Earth's surface and also from the atmosphere, from the clouds, from the dust particles. Sara milakar. The total albedo is 35. No, not 15, sir, 35. 35, sorry. 35 is the total albedo, correct. From the Earth's surface, from the clouds, dust particles, ice crystals, Sara milake. And remember, albedo component is reflection. Albedo will not be responsible for heating. Will not responsible for heating. Okay, fine, that's gone. The second component is 15 units. 15 units is the energy absorbed by the atmosphere, which is the ultra wide energy spectrum. और ये दो जगह absorb होता है. One is partly in the thermosphere and partly in the ozone of the stratosphere. Absorbed in two ways. One is 115 is in the thermosphere, the ions are there. And second is absorbed by the ozone of the stratosphere. This 15 is short wave radiations. The short wave, high energy, ultraviolet radiations. Ultraviolet radiations. Okay? So this creates the stratospheric warming. And the remaining 50 is absorbed by the Earth's surface. The remaining 50 is absorbed by the Earth's surface. much of it is the visible spectrum. Kitna percentage chhod do abhi for now. Okay, some things we just take it superficially. The 50 is absorbed by that the oceans and the land. And the land, 50. That's how the incoming radiation is broken up. All good here? Okay, fine. Let's move on. Now, what happens in the outgoing energy or the outflux? So 100 comes in, but remember, this can't remain with Earth forever. Otherwise, Earth will become more and more hotter. So the mechanisms by which the energy is lost. Okay? So this is the Earth's surface. Earth's surface. How much has the Earth's surface absorbed? 50. Now, how is the Earth's surface losing energy? Earth's surface losing the energy. Okay? So, approximately 5 goes directly outside. This 5 is in the range of about 7 to 10 microns. जो अंदर आया है, this is what range of wavelength? Is approximately 0.4 micron to 0.7 micron. This is 7 to 10. ये point नहीं है. 7 to 10, 7 to 8 उस range में है. This is direct loss of energy. Okay. This is called as, ये जो range को बोलते हैं, atmospheric window of incoming radiations. The atmosphere can't block it. It comes inside. This is called as atmospheric window of outgoing radiations. The atmosphere again can't block. Now, wisdom here is the atmosphere is selective in absorption. It can't absorb everything. I hope you got the point. 5 is lost from surface. Surface means continents, oceans, forests, life forms, okay, whatever. All from the surface is lost. Directly outer space. 8 to 10 hai, 8, 9 hoga microns ke range mein. This is called as the atmospheric window of outgoing radiations. And this is called as the atmospheric window of incoming radiations. What do you mean by window? Window basically means the spectral range in which, first write this point. This is the atmospheric window of incoming radiations, which is the visible spectrum. This is the atmospheric window of outgoing radiations. This is short wave. Visible spectrum is the short wave radiations. This is the long wave terrestrial radiations. They are low energy. The long wave terrestrial radiations, they are long wave radiations. So what do you mean by atmospheric window? Okay. Atmospheric window का मतलब क्या है? It is the spectral range which cannot be intercepted by the atmosphere. What's atmospheric window? Atmospheric window is the spectral range, the electromagnetic range, wavelength क्या है? The range which the atmosphere cannot intercept, the atmosphere cannot absorb, is called as the atmospheric window. इस range में it is lost directly outside. All good here? All fine? Okay. 5 units directly lost. The spectrum is 7 to 10 micron spectrum. And this is a long wave radiation. This is a terrestrial radiation. And this is, okay, the atmospheric window of outgoing radiations. Anuba, is it okay now? Is that fine? Yes. Offline, all good? Fine, let's move on. Now, is 50 ka, there is one component which the surface loses by conduction and convection. Like, you know what's conduction, right? Energy loss because of contact. What's convection? Energy loss because of mixing. Okay. There's some loss because of this and some loss because of this. What type of wavelength is this one? Long wave, short wave? What type of wavelength is this one? Short wave or long wave? Long wave or short wave? Pakka? मेरी जान ये रेडिएशन ही नहीं है. Okay? Long wave, short wave is only for radiation. Good. These are conduction and convection mechanisms. You will not use the word long wave, short wave here. Long wave, short wave only when I have radiation, okay, transmission. Okay? So this is simply convection, conduction. You will not use the word wave at all. Okay. This is called as a sensible heat, which we can sense as in I can touch and feel. It's called as sensible heat. So some loss is by radiation loss. Some loss is by sensible heat loss, conduction and convection. Some loss is by latent heat. Latent heat happens when water evaporates. It's called as latent heat loss. So how does water evaporate? You see, water is here. Water takes energy, changes its state and becomes vapor, and it moves out. When energy becomes vapor and moves out, energy is lost from the surface. This is because of evaporation of water. This is simply because of touch. Because of contact, this part is warmer. This is a bit less warmer. This is a bit less warmer. Because air moves, this is a bit more warmer. Moves but less warmer. This is because of actual movement of molecules. This is because of water evaporating. We call this as latent heat. The latent heat component is approximately 20 units. The sensible heat component is about 10 units. So 50 mein se 5 has gone directly out as radiations. 10 has been lost from the Earth's surface as sensible heat. 20 lost from Earth's surface as latent heat. Any problem here? Uske baad, some energy is also again radiation. But this radiation, Earth will lose and atmosphere will block it. Okay. And then atmosphere becomes warm. It'll again re-radiate back. Earth becomes warm and Earth again radiates back. There's a continuous radiation, counter radiation, re-radiation. Is exchange mein, there is a net loss by the Earth. It's something like I earned some money, I put in the bank. Then I draw from the ATM. Then I probably invest in terms of some policy. I take loan from the bank. I'm giving interest to the bank. I'm taking overdraft from the bank. The continuous exchange is going on. And in this exchange, it's possible the bank is gaining net, or maybe I am gaining net. Possible? Okay. So it's like it's a continuous exchange. Okay. The Earth surface is warm. It gives energy to the clouds, atmosphere, dust particles. They become warm. They will again radiate back towards the Earth. Okay. Again, this energy again goes back. It's a continuous radiation, counter radiation, re-radiation going on. In this exchange, the net loss is by the surface, about 15 to the atmosphere. Is it okay, all of you? Ye batao. Okay. This is long wave or short wave? This is long wave and this is radiation. This is long wave radiation. This also long wave radiation. So maybe radiations of wavelength less than 7 will be here. Radiations of more than 10 will also be here. 7-10 range, atmosphere can't handle. It goes out. Yes. So this also is long wave radiation. This is the net. This is the net radiation loss of the Earth's surface to the atmosphere. 15 is the net radiation loss. The word net is important, okay? Because this is a continuous interaction going on. The net radiation loss by the Earth's surface to the atmosphere. Short waves are only those coming from the sun. Okay, short wave are only the solar radiations. All the rest are long wave radiations. All good? Okay, so if I sum this up, Earth's surface absorbed how much? 50 units of energy. Direct loss, long wave to outer space is how much? 5. This is long wave and this is the atmospheric window. It's the range of, I said, 7 to 10 microns and so on. There is a sensible heat loss to atmosphere is how much? Okay, 15. Sorry, 10. There is latent a heat loss to atmosphere. This is 20. And there is net long wave radiation loss to atmosphere is how much? 15. So add this up. Kitna ho gaya aapka? 15, 5, 20, 30, 40. Okay. 50, right? 50. How much had Earth absorbed? Earth's surface absorbed 50. How much has it lost? 50. So Earth's surface in balance. Yeah, greenhouse gas. The greenhouse gas will play a role here, will play a role here, and also will play a role here. The greenhouse substances, the carbon dioxide, the pollutants, the dust particles, all of them, they play a role here. Okay? So this is the balance of the Earth's surface. 50 was absorbed and 50 has been lost. Okay, now, how much has the atmosphere absorbed? 10, 20, 15. How much is this? 45, right? Atmospheric absorption kitna hai? It is 35, correct? Yeah, sorry, 45. It is 45. 45? Yeah. So, total atmospheric absorption by loss from the Earth's surface is how much? 45 units. 10 plus 15 plus 20. 45 units. Total atmospheric absorption of a shortwave radiation. Kitna hai? 15. Remember ultraviolet? ये भी 15 है ना यहाँ पर 15 ये वाला. How much has the atmosphere absorbed? From the Earth's surface, it has absorbed 45. From the incoming absorbed how much? 15. Total is how much? 60. Okay. And this 60, okay, this 60 of atmosphere is ultimately directly lost to the outer space as long wave radiation. This 60 will not remain with atmosphere forever. The 60 is directly lost to the outer space by long wave radiation. Likha aapne, all done? What this means is this component, this 15, 20 and 10, ये पूरा component जो है will be directly lost to outer space. This is 60 loss. All fine? Therefore, the total loss from Earth atmosphere system, Earth system, one is loss from atmosphere, 60 long wave radiations. Loss directly from Earth's surface, कितना है? 5. आप ये ना बोले, ये भी लॉस ही तो है. 60 from atmosphere, 5 has lost from Earth's surface directly. And loss albedo भी तो एक है ना, right? Okay. So direct loss from atmosphere is 60, from surface is 5, plus loss because of albedo, Earth and atmosphere. ये कितना हो गया? 35. Total how much? 100. How much had come in? 100. How much lost? 100. Fine, all of you? That's how the balance is maintained. The work done is atmosphere, winds moving, precipitation, rainfall, the biological processes, all of that is work done. I'll come to that. Wait, Indranil, wait. Yes. Albedo का same form रहता है. Short wave आया, short wave जाएगा. The form won't change. Yes. Continuous में it's not perfectly equal. Continuous में example बताया ना. Okay, I take loan, I can take rental income, I have my own income, I have probably some other inheritance. ये अलग source of income है. Expenditure I can spend, my family spends, I give maybe loan, I give interest. So net में there will be somebody gaining net. So it's like we're discussing, there is an Earth surface component. Something comes in, something goes out. 50 comes in, 50 goes out. There is an atmospheric component. इस atmospheric component का एक Earth surface atmosphere interaction है और एक है atmosphere and outer space interaction. Okay. So the surface atmosphere interaction, we have seen this to be 60. 60 it gets. Loss again is 60. So this also ultimately is balanced. 60 comes in and 60 goes out. And then the final loss to it, 35 and 5. So if you add up all of this together, along with the loss from the Earth's surface, finally, what comes in is 100 and what goes out is also 100. So atmosphere in balance, okay, ये जो 60 absorb किया था, the 60 absorbed and lost. Okay, this 50 absorbed and lost. The full coming is 100, the full going out is also 100. That's how the Earth atmosphere maintains its balance. Yes, the forms can change. Okay. The energy comes into my house as electricity. और घर में the fan is mechanical energy. The form can change. Energy comes in as electricity. The bulb glows. That's light and heat energy. The form can change, but energy remains constant. The fundamental law of thermodynamics. Conduction, convection directly outer space में नहीं जाएगा. For conduction, convection, I need a medium. Outer space is almost like a vacuum. So outer space loss is always radiation loss. Conduction, convection is inside the atmosphere. Bulk of it is in the troposphere. Yeah, what I told you, 100. 100 was what? It was 2 Langley per minute, correct? So this balance is for every minute. Every minute we maintain the balance. Can I move on? Yes. Yes. Albedo का form change नहीं होगा. Albedo अगर direct है तो उतने वही रहेगा, short wave ही रहेगा. But understand, short wave में okay, ultraviolet नहीं है. That's lost. वो already absorb हो चुका है. So albedo में कुछ visible spectrum होगा, कुछ IR होगा. नहीं होता. Because absorb करने के बाद जो change होगा वो long wave convert होता है. Reflection is same energy coming back. I throw the ball, the thing bounce back. In albedo, the form will not change. इतने सारे terms जानते हो, okay, मुझे ही आपसे क्लास करना पड़ेगा. Okay, one by one. Atmosphere का repeat कीजिए. क्या repeat करूं, निखिल बताओ? What do you want me to repeat? Anybody offline? Any doubts? Yes? Who's asking? Sorry. नहीं. Reflection में the form will not change. Yes. Only, देखो, there's difference between reflection and re-radiation. Reflection remains the same. Absorb नहीं कर रहा है. Reflection is direct bounce. In reflection, there's no absorption. अगर absorb कर लेगा, then it will change the form. Why? Because it is reflection. Reflection में you don't change the form. इसमें why नहीं है. That's the law. 15 absorbed by atmosphere is incoming. अगर 15 क्या repeat करना है शशांक? This 15 is the ultraviolet absorbed by the atmosphere ozone layers, absorbed by the thermosphere ions. आप पूरा बोल दिया, मुझे बोल रिपीट करो, मैं रिपीट कर दिया. समझ में क्या नहीं आ रहा बताओ. और ये जो है बेसिक गणित है, एडिशन प्रॉब्लम, देन यू कम टू CSAT क्लास. Oh, wait, a few more minutes. Can I move on from here? Now listen. This is the balance that we have. What I mean by balance is, now please, no questions for some time more. What I mean by balance is, whatever comes in goes out. Okay? But the balance is not instantaneous at all locations. It's like my wife earns, she works. कोई जरूरी नहीं है that she spends the same day. Or I earn income doesn't mean I spend immediately. I earn, I save, I buy things. Okay. Eventually, even that I give off, or I lose, or I sell off. There's a time gap. Okay. Whatever I absorb, I don't give out immediately. Because if I give out immediately, then Earth will have 0 Kelvin temperature, minus 273. जो अंदर आया चला गया साथ, Earth will have no temperature in that case. Earth absorbed, and Earth does some work. What work is that? The winds are moving. The ocean currents are moving. The biological life is forming. The rivers are moving. The snow starts melting. So Earth absorbs energy. Earth does some work. and then the earth releases energy. Okay. So what happens is, so watch this. This is the earth, say time T1. Time T1, okay, a packet of 10 unit comes in. Okay, it comes in, and the packet 10 is doing some work. Of the 10, probably 5 goes out, and maybe, okay, say remaining 5 remains for some time. Then at time T2, another 10 comes in. Of this 10, okay, maybe 5 goes out, and this 5, okay, goes out here. और इसका जो 5 है, it remains. Then there is time T3. Time T3, again 10 comes in. 10 comes in, okay. Of this 10, 5 goes out, and this 5 goes out here. And इसका और 5 जो है आगे बढ़ जाएगा. Can you understand this here? Okay, so 10 comes in, 10 goes out, but this 10 का एक part अभी गया और एक part इधर से आया है. So at any given time, 10 comes in, 10 goes out, but some stays and it keeps on doing work and getting released eventually. So at every moment, the balance is maintained, but there's some work going on here. Is it okay, all of you here? The loss is not instant, because instantaneous hoga, earth will not have any temperature. What comes in, what goes out. I mean, typically imagine the guy at the bank counter. पैसे निकाल के पकड़ा दिया. Okay, उसके हाथ में कुछ नहीं जा रहा, right? How frustrating life. He's counting, लाखों में counting. Okay, but pass on. He takes from you, keeps it here. Okay, and this one guy again gives it back. This guy has nothing, instant loss, instant gain. Okay, so think of, if this happens, फिर तो earth can do no work. This transaction से ये बंदा can't even buy a small chocolate. Right? It's doing no work for him. It's only transacting. Okay, so earth system is not like that. Earth absorbs, earth will do some work. Some lost right now, correct, but some will stay, will do work. When next comes in, then a part of it goes out, part of it remains again, does some work, and that's how it continues. Is it fine, all of you? So the analysis part, analysis mein, point number one, that the earth is in balance at all moment. The earth is in balance at all moment, but not all energy is lost instantaneously. The earth is in balance at all moment, but not all energy is lost instantaneously. Earth absorbs energy and does work. Earth absorbs energy and does work before releasing the energy. Earth absorbs energy and does work before releasing the energy. Fine here? And what do I mean by earth doing work? Earth doing work का मतलब है atmospheric processes, biological processes, the moving of rivers, melting of ice, all of that is work done on the earth. Glaciers moving, rivers moving, waves are moving, सब कुछ work done by the earth है. From fundamental sources, your solar energy. That's one point. There is a time lag in this. Okay. Number two, the loss of energy and the gain of energy is not at the same location. The gain and the loss of energy is not at the same location. Say something like, this is the family. The family. Family has a father, a mother, maybe some children, maybe some other dependent. The parents are here. maybe income is by the father and the mother. Some they spend, but some they the children will spend. Some probably other dependent will spend. So when Earth receives energy, Earth may receive more energy at the tropical location. Again, Earth will lose more energy at the polar location. But net is that the Earth is in balance. I hope you got the point here. So there is okay, transfer of energy, okay, across latitudes. Let's go down here. So there are interlatitudinal variations. There are interlatitudinal variations in how energy is received and how energy is lost. There are interlatitudinal variations in how energy is received and how energy is lost. The low latitudes, the tropics and the equator, the low latitudes within 40-45 degrees, the low latitudes within 40-45 degrees are net gainers. They are the net gainers. Means they receive more and they lose less. They're net gainers. Okay, next point. The high latitudes and the polar regions. The high latitudes and the polar regions are net losers. They are net losers. They are deficit latitudes. They are deficit latitudes. This is like this. Agar ye Earth hai, okay, say maybe a 70 comes in, and maybe here 30 comes in. Loss here is probably 20 units loss, and loss here is 80 units loss. Can you all understand this now? Okay, so some comes in, less goes out, and this energy is getting transferred here. The energy gets transferred here. Kuch energy yahan se bhi idhar bhi aa raha hoga transfer. Okay, so there is interlatitudinal transfer. So if you look at the Earth atmosphere, okay, what comes in here doesn't go out here. It comes in, does some work, it moves across latitude, and what moves? The winds are moving, the currents are moving. Okay, and energy is lost here also. So the high latitudes, these are the net losers, and these are the net, okay, gainers. That's the reason why these areas are warmer and these areas in general are cooler. There are interlatitudinal variations in how energy is exchanged. The crux is Earth is in balance. Whatever comes in is also lost. But the balance is not maintained at every latitude. Is it fine, all of you here? Okay, write down next. These are the components how. These are the components how the Earth manages through. The Earth manages through various atmospheric processes, biological processes, by atmospheric processes, by biological processes, and the actions of, and by the actions of the agents of denudation, and by the actions of the agents of denudation. River, glaciers, you have got waves moving, okay, ice cap, ice shelves, is sab milakar, they're doing something. So all of this is driven by the solar energy. These processes, atmospheric processes, the ocean processes, the biological processes, and the role of the agents of denudation, they're responsible for all of this mechanism. Last point. Climate change can be seen as the consequence of the heat budget disruption. Climate change can be seen as, climate change can be visualized as the consequence of heat budget disruption. So imagine what's happening here. Okay, so if you look at this one, watch here. So imagine, okay, the total albedo is 35. But what if you have, you're responsible for melting the ice? What if the ozone is less? If ozone is less, 15 nahi hoga absorbed, right? Okay, maybe 10 hoga absorbed, and now 50 has now become 52 maybe, or 53 maybe. Okay, what if you add more of carbon dioxide? Then the sensible heat 10 se ho jayega 15. What if the clouds are less because of more aridity? So the, again, reflection will be less, and outgoing can also get compromised. So whatever problems you have are because somewhere you're compromising the processes. So this absorption 50. Okay, if you are having urbanization, emissions, the 50 becomes more than 50 now. So you have volcanic eruption. Volcanic eruption will create a cloud, and this cloud will not allow for 5 to go out very easily. So whatever climate change we have is a consequence of the disruptions of the heat budget. Write down, man's activities or otherwise. Man's activities or otherwise can change the influx of energy. Can change the influx of energy. So what are the factors? How the influx can change? How can it change? Ozone hole. How can it change? Sun has become hotter. 100 has now become 120. Is it possible? Yes, solar winds ho raha hai. You have got sunspot cycles are there. So influx can change. Where ozone hole kar diya, influx changes, the sun becomes hotter. Influx changes, the albedo loss has now become different because the surface has now changed. Okay, and so also influx can change, and so also outflux can be altered. The outflux can be altered by changing the surface nature and the atmospheric chemistry. By changing the surface nature and the atmospheric chemistry or atmospheric composition. Atmospheric composition. Essentially, ये जो process है ना, this is something like a very, very fragile system operating. It's all linked to one another. आपने कहीं कुछ छेड़छाड़ किया, the system can go awry there. Okay, write down the heat budget. The heat budget, okay, is depiction of the heat budget is depiction of a very well balanced Earth atmosphere working like a system. A very well balanced Earth atmosphere working like a system, which human activities can disrupt. Which human activities can disrupt. Fine, that's for today. Don't open the books as of now. It's also part in NCERT mein bhi likha hoga, but maybe not in as much detail. You revise from the class notes, we continue tomorrow. Yeah, we'll continue tomorrow. Bye. Thanks for sitting through. Bye.